Equation forms, intercepts, and graphing. So the first thing we're going to talk about is standard form. Standard form is AX plus BY equals C. A, B, and C are constants. That is, they are numbers. X and Y are on one side, and your C is on the other. There are no fractions, none at all. You always get rid of the fractions when you put it in standard form. And normally the X term is in front and positive. So let's take a look at an example. Negative 2/3 X plus 1/4 equals 5/6Y. So I've got all my constants, but they're fractions. So the first thing I'm going to do is get rid of fractions. So I look at all my denominators, 3, 4, and 6, and I find the least common multiple. And the best way to do that is take your largest number, 6, take multiples of 6, 6, 12, 18, 24, 30, 36, 42. Find the very first one you can think of where 3 and 4 divide into it. And they all divide into 12 evenly. So what I'm going to do is multiply everything by 12. When I do that, I'll cancel and get rid of my fractions. 3 into 12 goes 4 times. 4 into 12 goes 3 times. 6 into 12 goes twice. So what I have so far is 4 times negative 2, negative 8x. 3 times 1, remember the 4 canceled, the 1/4, the 4 canceled, so it's plus 3 times 1, 3 equals, the 6 and the 12 canceled, I got 2, 2 times 5 is 10, so it's 10y. Now, you could do this a couple different ways. You could move the 8x over with the 10y if you wanted. That would get the 8x, the negative 8x positive, which is what I'm going to want to have happen. But let's say I didn't notice that. I need to do two things. I'll move the 10y over with the 8x, and I'll move the 3 over with the 10. First of all, I'll get rid of that. So I'm going to take off, I'm going to subtract a 3 to move it to the other side, and I'm going to subtract a 10y. So what I have is negative 8x. Now the 3 is gone, and I subtracted 10y from both sides, so minus 10y. Remember, you can't combine those, they're not like terms, equals, and I subtracted 3, and so I have a negative 3 on the other side. Now, as I mentioned, notice normally the x term is in front and positive. See how I have negative 8x? What I would do then is divide everything by negative 1, and that would just change all the signs. The final answer in standard form would be 8x plus 10y equals 3. And that is in standard form. So you eliminate fractions. You get the variables on one side and that number, the constant, on the other. There are no fractions. You get the x in front and positive. Divide by negative 1 if you need to. And you have an equation in standard form. Standard form is used to find intercepts. It's the best form for intercepts. And you can see why if you make a table. If I'm looking for the x-intercept where it crosses the x-axis, what I know is that on the x-axis you don't go up or down at all. Y is 0. If I'm looking for the y-intercept, I don't go left or right at all. I'm on the y-axis and I know x is 0. So to find the x-intercept, y is 0. To find the y-intercept, x is 0. So all I need to do is plug these numbers in. Now, look what happens. I plug in y is 0. I get 2x plus 3 times 0 equals 12. 2x equals 12. X equals 6. So x is 6. And I'll do the same thing for plugging in x is 0 to find the y-intercept. But notice something here. If I put in y is 0, this term just drops out. And I end up with 2x equals 12. And x was 6. Now I could do the same thing again. Let's change colors. If I put in x is 0, 2 times 0 would be 0, that term would drop out. I get 3y equals 12, and 3 times 4 is 12. So when you plug in that 0, that term just disappears, and I'm left with a simple equation that we can solve in our head. So that's why the standard form is so awesome for finding intercepts. Like below here, if I'm looking for the y-intercept, x is 0. If I'm looking for the x-intercept, y is 0. Let's do the x-intercept first. So I'm going to put a 0 right here. It becomes 6 times 0. That's gone. So I'll make a table. Y is 0. And I get 4x equals 18. Well, that wasn't real friendly. That's 18 over 4. If I solve, divide both sides by 4, which is 9 halves. Divide by 2, or 4.5. 9 halves. And if I plug in x is 0, put a 0 for x. 4 times 0 is 0. Negative 6y is 18. Divide both sides by negative 6, and you get y is negative 3. Let's look at these next couple. So let's make this table. We'll put in 0 for y and 0 for x. If I put in 0 for y, 3 times 0 would be 0. I get 8x is 24. 8 times 3 is 24. If I put in x is 0, 8 times 0 would be 0. I get negative 3y is 24. Divide both sides by negative 3, and y is negative 8. One more time. I'll put in 0 for y. 5 times 0 is 0. 3x is 15, so x is 5. I'll put in x is 0. 3 times 0 is 0. 5y equals 15 is my equation. Divide by 5, and y is 3. So we'll put an equation in standard form whenever we're finding intercepts. It's also a really quick way to get 2 points to make a graph of a line. The next form we talk about a lot is slope-intercept form. Slope-intercept form is y equals mx plus b. What you need to know about that is that b is the y-intercept. It's where the line crosses the y-axis. Think of it as the starting place on the y-axis, where a line starts on the y-axis. And m is the slope. It's what you multiply x by to get y. Reminder, m, the slope, is defined as rise over run. So when we have a line and we pick any 2 points on the line and we make a triangle, the horizontal part is called the run and the vertical part is called the rise. Sometimes you see it written as delta y over delta x, whereas the triangle, the Greek letter delta, is used to mean change in. It's the change in y over the change in x. It's the rise over the run. Slope-intercept form is the form we use most often. It's the equation the calculator requires you to enter to graph a line. It's a really easy equation to work with because y is by itself. We can visibly see the slope in front of the x, and we can easily see the intercept. Think about y be as the intercept. If I give an equation like y equal 2x plus 3, where 2 is the slope and 3 is the intercept, the y-intercept is where it crosses the y-axis. And remember what we said just a little bit ago. For the y-intercept, x is 0. Remember we were finding intercepts? And if I plug in x is 0 in this equation, I get y is 3, because 2 times 0 is 0, y would be 3. So you can always easily see the y-intercept because plugging in x is 0 makes the x term drop out, and I immediately see that y is whatever this b is. We often will have to put an equation in slope-intercept form. Here are some examples of equations that I'm going to put in slope-intercept form. So the goal here is to get y by itself. And you might have seen questions like this before. the first thing you do is distribute. Y minus 3 equals negative 5x, and negative 5 times 2 is negative 10. And then I'm going to get y by itself, so I add 3 to both sides, and I get y equals negative 5x minus 7. There's my m, it's negative 5. There's my b, the y-intercept, it's negative 7. You might end up with a fraction for slope. Very common. Slope is rise over run. When we use it, it's always a fraction. So I take 2/5 times x and 2/5 times 6. Remember, 6 is 6 over 1, so this is just 12 over 5. And then you need to get y by itself, just like we did. And this is where a calculator is handy. You can always use Desmos.com. Remember, there's a little fraction bar beside to make a simplified fraction. Do not use decimals. We always want exact answers when we're working with lines. Negative 12/5 minus 4, and then I'm using the calculator. Math fraction is negative 32/5. So y equals 2/5 x minus 32/5. Right, this next equation below is in standard form. See how the x's and y's are on one side? There's no fractions. X is positive. I'm going to put this in slope-intercept form. So I'm going to solve for y. First of all, I get the 2y by itself. I take a 3x actually off both sides. I get negative 2y equals negative 3x plus 8. And now I need to get rid of the negative 2. And y will equal, 2 negatives make a positive when you divide. A fraction is a division problem. So it's 3/2 x minus 4. Now this one's going to be interesting. To make this easier, I would get rid of fractions right off. I'm looking for the least common multiple of 3, 4, and 6. Again, take your largest number, take multiples of it, 6, 12, 18, and they all divide into 12 again. So I'm going to multiply everything by 12. 3 goes into 12 4 times. 4 times 2x is 8x. 4 goes into 12 3 times. 3 times 3 is 9. 6 goes into 12 twice. 2 times 5 is 10, so 10y. Now I'm going to flip this around. 10y equals 8x minus 9. And I'm going to divide everything by 10. So this is y equals 8/10 reduces. Divide them both by 2, and you get 4/5 x minus 9/10. Here's some examples from your WAMAP assignment. Look at these two equations I've written down. Y equals 3x plus 5, y equals 2/3 x plus 1. If I take the first equation and plug in 1, 2, 3, and 4, I get 8, 11, 14, and 17. Notice how each time, these are called differences. In fact, these are called first differences. Every time I'm increasing by 3. And over here, also for x, I increase by 1. With a linear equation, with a linear function, both sides have to increase by a constant if the points are in order. For the other example, you notice I picked 3, 6, 9, and 12, and how, again, they're all increasing by 3. I intentionally did that because when I plug in these numbers, 3, 6, 9, and 12, when I plug in 3, the 3's are going to cancel, and it ends up being 2 plus 1, which is 3. And if I plug in 6, the 6 and the 3 will cancel, and the 6 will become 2, and it'll be 2 times 2 plus 1, which is 5. And when I plug in 9, and you're going to see what happens here, the 3 and the 9 cancel, and the 9 becomes a 3, and 3 times 2 is 6, and 6 plus 1 is 7. Look here, 3, 5, 7, I'm increasing by 2. And that's no accident. Look at the fraction. It is 2/3. The x is increased by 3, and the y is increased by 2. That's because the slope is 2/3. But again, the point here is that both sides, the differences, of 3 and 2, they both have to be constant for it to be linear. So when you look at the tables over at the left, you're looking for the tables that increase by constants on both sides. So I did some quick mathematics for you. Look at all the x's in the tables. They're all increasing by constant, so x is not the problem here. If we look at the y's, though, for the top table, it increased by 25 and then 75. This one's out. For the second table, it increased by 10, then increased by 20. That one's out. For the third table, I'm increasing by 20 every time. This one's good. And for the last table, I'm decreasing by 10 every time. I can add negative 10 every time. That's perfectly okay. So these two here are linear because both the x's and y's change by a constant. For question 4 and 5, I didn't do all these. I picked certain ones for examples. We're going to do standard form. That's ax plus by equals c. Ax plus by equals c. No fractions, x in front and positive. So we'll get rid of fractions first. We'll multiply everything by 5. That will cancel this fraction. I get 5y equals negative 3x plus 30. And I'm going to do standard form. I need the x's and y's on one side. I'll move the 3x over. I want x in front and positive. I'll add 3x to both sides. And I got 3x plus 5y equals 30. For question 5, same exact thing. I'm going to get rid of fractions. I'll multiply by 7. The 7's cancel. I get 7y equals 3x minus 21. And I'll move the x over with the 7y. I'm going to subtract it from both sides. Notice that when you move a variable to the other side of the equation, all that happens is the sign changes because you always do the opposite to move it. So this is negative 3x plus 7y equals negative 21. Now, I told you that normally x is positive. This is standard form, but ideally you're going to divide everything by negative 1 and get x positive. So our final answer would be positive 3x, negative 7y, and positive 21. So actually we just went through and changed every sign when we divide by negative 1. Here we have some equations in standard form. We're going to put them in slope-intercept form. Slope-intercept form is y equal mx plus b. We're going to get y by itself. So this is quick. First of all, we get 5y by itself. We'll add x to both sides. And we get 5y equals x minus 15. Now, I can divide everything by 5. Don't forget, there's a 1 in front of that x. So that's actually a slope of 1/5. So my answer is y equal 1/5 x minus 3. For question 9, same exact thing. It's in standard form. We're going to put it in slope-intercept form. So we will, again, get 3y by itself first. Take an 8x off each side. I get 3y equals negative 8x minus 6. And I'm going to divide everything by 3. And so for my final answer, I get negative 8/3 x minus 2. One more, putting an equation in slope-intercept form. This is actually in a form called point slope, which we'll talk about soon. This is y minus 7 equals, we have to distribute first, negative 5 times x and negative 5 times negative 2. Negative times a negative is a positive. Positive 10. Get y by itself, add 7 to both sides, and our final answer is y equal negative 5x plus 17. Here are a couple of questions for practice. We have an x and we need to find the y. We have an x, we need to find the y. Sometimes you may be given the y and need to find the x. So look at what they give you, plug in that number, and solve for the other number. So this becomes y equals, we're going to plug in x is 8. Negative 6 times 8 plus 2. Negative 6 times 8 is negative 48. Or negative 48 plus 2 is negative 46. So our answer is in the box, negative 46. Same question, except for we have x is negative 2. Be careful, again, sometimes they're going to give you y. This is y equals negative 6. They give us an x of negative 2. Put it in the x spot. This is negative 6 times negative 2, which is positive 12, and 12 minus 7 is 5. So in the box, we put a 5. So we found intercepts earlier. We're going to do the same exact thing here. We make that table, and we're going to look for the x-intercept. This will be the x, int. Y will be 0, and this will be the y-intercept, and x will be 0. So we take that equation, negative 4x plus 8y equals negative 16. Put in y as 0. When I plug in y as 0, that term drops out. I get negative 4x equals negative 16. Divide both sides by negative 4, and you get x is 4. Repeat, do exactly the same thing. This time, put in x is 0. When I put in x is 0, that x term cancels out. Negative 4 times 0 is 0. I end up with 8y equals negative 16. And divide by 8, and y is negative 2. Now we have to graph it. So we take those points, 4, 0, x is 4, y is 0. And x is 0, y is negative 2. And we take a ruler, and we draw a line. In question 22, we have a point, negative 3, 0, negative 3, 0. It doesn't matter where the point is. It can be anywhere. When you have the slope, you can either put that negative up top, negative 3 over 5, or you can put that negative below, 3 over negative 5. However, what you do will matter in the direction you go. If you put the negative up top, your rise over your run of slope, the rise ends up being down because of the negative, and the run is positive 5, that would be to the right. Think of the x-axis, positives are to the right. If you put the negative below, then your rise over your run, your rise is positive 3, you go up, and your run is negative 5, you go left. Again, think of the x-axis. Negatives are to the left. It ends up being the same line, though. So I can go, let's do this one first, down 3, 1, 2, 3, 1, 2, 3, 4, 5. Or I can use this one and go up positive 3, 1, 2, 3, and over negative 5 to the left. 1, 2, 3, 4, 5. And those 3 points will make my line. These next 2 questions are something that students often have trouble with. And whenever I explain it to them, they always go, "Oh, Mr. Caldwell, that's easy." And then half the class misses it on the test. Maybe that's an exaggeration, but still, it's something that students have trouble with. A good way to think of this is think of this equation in standard form. AX plus BY equals C. Notice how there is no x, so what I'm going to do is put a 0 there. There's a 0x. 0 times x is 0. Look at the equation. The equation is y equals 4, so it's 0x plus y equals 4. And if I were to make a table for this, x, y, anything I put in for x, 1, 2, 3, 4, would immediately get multiplied by 0 and be gone, and y would always be 4. And I'd get a graph that looks like this. X is 1, y is 4. X is 2, y is 4. X is 3, y is 4. X is 4, y is 4. In other words, y is always 4. Everywhere on this line, y is 4. If I grab a point way over here, that is negative 4, 4. Y is 4. If I grab one right here, that is negative 2, 4. And again, y is still 4. We can graph this line the same way. Think of it as ax plus by equals c, but there's no y. That means there's a 0y. So this equation of x equal negative 2 becomes x plus, there's no y, there's 0y, equals negative 2. Still x equal negative 2. 0 times y is 0. And that's helpful if you again look at the table. But this time what we have to do is pick values for y. It doesn't matter what I pick for y, 1, 2, 3, 4, any number at all. When I put in a number for y like 1, 0 times 1 will be 0, and x will always be negative 2 every single time. So negative 2, 1, negative 2, 2, negative 2, 3, negative 2, 4. And on that vertical line, vertical up and down, every single point will have an x of negative 2. If I grab a point right way down here, that's negative 2, negative 3. And a point right here, that is negative 2, negative 1. X is always negative 2 on that line. So you got to find a way to keep it straight. When you say x equal a number, it's always a vertical line every time. There's no slope. It's undefined slope, you might vaguely remember. If you have a horizontal line, flat like the horizon, that's a y equal equation. It's actually a slope of 0, but x equals is a vertical line, y equals is a horizontal line.